Hello. In this video, we want to find all relative extrema for the following function, as well as where the function is increasing and decreasing. We have f of x equals x e to the 2 minus x squared. Again, we want to find critical points, which means we want to find the derivative. We're going to have to use the product rule here, which is the first times the derivative of the second. So just rewrite that, and then multiply by the derivative of the exponent, which is negative 2x. And then plus the second, e to the 2 minus x squared, times the derivative of the first, which is just 1. Now notice that there is a common factor of e to the 2 minus x squared in both of those. So it's going to give me e to the 2 minus x squared times what's left over. Well, we have an x and a negative 2x multiply to give you negative 2x squared. And then plus 1 at the end. Good deal. Well, here's the thing. If we want to find this derivative, we want to go ahead and set this entire thing equal to 0 now. So we get e to the 2 minus x squared times negative 2x squared plus 1 all equal to 0. But here's the thing. Each one of those would have to equal 0. Or could equal 0. Over here, one thing you should know is that an exponential like this is never equal to 0. No matter what the exponent is, it doesn't matter. Now, if you wanted to, you could go ahead and solve this as 2 minus x squared equals the natural log of 0. But here's the thing. You can't type in the natural log of 0. 0 is not in the domain of the logarithm. So this would produce no solution to this equation. So there are no critical numbers from that portion. The other one, though, does have some solutions. First, subtract the 1 makes negative 2x squared equals negative 1. Divide by negative 2, so x squared equals a half. Excellent. Now, if x squared equals a half, that means x is equal to plus or minus the square root of a half, which would be the square root of 1, which is 1, over the square root of 2. And if we want to rationalize the denominator, multiply both the numerator and denominator by the square root of 2, making that the square root of 2 over the square root of 4, which is just 2. So technically, there are two critical numbers here, x equals negative root 2 over 2, and x equals positive root 2 over 2. So negative square root of 2 over 2, and positive square root of 2 over 2. Excellent. Now, to use the first derivative test, we want to find numbers to the left, in the middle, and to the right of those numbers. So I'm going to use, let's say negative 1, 0, and 1. Awesome. Now let's look at this. F prime of negative 1. What is that? Well, if you have your calculator and you've already typed it in, you can go to the table and use that table. So at negative 1, the derivative is approximately negative 2.718281828. That means that this is negative here, which means it's going down from left to right. Now let's look at f prime of 0. Well, f prime of 0 here is going to give us 7.3891, approximately. And of course, that makes that positive, which means it's going up from left to right. And now let's look at f prime of 1. Well, f prime of 1 is, again, negative 2.718. So it's going down from left to right because it's negative. Good. By the way, f of negative root 2 over 2, because this is in fact a critical, this is in fact a relative, in this case, minimum, because it's going down and then up. And then positive root 2 over 2 is a relative maximum because it's going up and then down. So negative root 2 over 2, the function value there, the original function value, if you type it in, negative square, sorry, 1 second. negative square root of 2 divided by 2. And that's going to give me the value of negative 3.169 to 3 decimal places. And positive root 2 over 2 will probably just give me the positive value, but let's just type it in. So square root of 2 over 2. Yep, positive 3.169. Good deal. So this function is increasing from negative root 2 over 2 to positive root 2 over 2, and it is decreasing from negative infinity to negative root 2 over 2, comma, and then also root 2 over 2 to infinity. And as for the relative extrema, there is a relative maximum of, now notice the maximum occurs over here, of, and the root 2 over 2 is 3.169. At x equals positive square root of 2 over 2. And there would be a relative minimum of negative 3.169 at x equals negative square root of 2 over 2. Outstanding. Alrighty. Well, I think I'm going to go ahead and take you to the calculator to kind of see what's happening. So I will see you there. Okay, so welcome to the calculator. I've already typed in the original function on y1, and on y2 I've typed in the derivative. So if I type graph here, notice that the blue is the original, that is the function itself. And so notice that there is a relative minimum here and a relative maximum here. Notice that the red is the derivative, and it's going way down up there. And notice that where it's crossing the x-axis is where this relative minimum occurs. And over here, where it's above and then going back down, where it's crossing this x-axis is where the relative maximum occurs. And there you go. Now, if we want to see the table, notice I have this on auto still. So at negative 1, the derivative was negative 2.718, which is exactly negative e, basically. 0 is 7.3891, which is in fact e squared. And 1 is, again, just the negative e. So those are negative, positive, negative in those regions. So on the table, the red should show you that. So the red is below the x-axis here, and it's going down, and while it's going down really low to right here, and then back up to here, and then at this point it hits 0. In other words, the slope of the tangent line here for the blue is horizontal. And it goes above, so since it's crossing there, that means that this is in fact a relative minimum. And it goes up to this maximum point here. Now it's not a maximum, but it's the maximum of the derivative, and it's coming back down to this point right here, which makes that another critical number. But because it's crossing to the other side, that makes this also a relative maximum. And it's going down like that, and it's going to go back towards 0 because this is going towards, asymptotically, the x-axis. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.